Hello, future system architects and developers. Today, we're diving deep into a topic that's critical for modern applications, building a real-time recommendation engine. This isn't just about showing users what they might like, it's about creating an engaging, dynamic experience that keeps them coming back. Think about the platforms you use daily. Their success often hinges on how well they understand and predict your interests. By the end of this lesson, you'll have a solid grasp of the core components that make these powerful systems tick. You'll understand how to leverage collaborative filtering to personalize user experiences, how to process data instantly with real-time feature pipelines, and crucially, how to prove your algorithms actually work using A/B testing. This knowledge isn't just theoretical. It's the kind of insight that drives user engagement, revenue, and ultimately the success of a product. Let's get started and build something truly impactful. At the heart of many recommendation systems lies collaborative filtering. Imagine this. You and a friend both love similar music artists. If your friend discovers a new band you haven't heard, chances are you'll like it too. That's the intuition behind it. The system learns user preferences by finding patterns in behavior, not just looking at content attributes. It's essentially saying, users who are similar to you liked this, so you probably will too. This approach is incredibly powerful. For a major streaming service, it can save $1 billion a year by keeping subscribers engaged. For a popular short video app, it drives over 90% of user engagement. Without smart filtering, users on a large social network would be overwhelmed by thousands of posts daily and quickly abandon the platform. It's not an optional feature, it's fundamental to user retention and platform success. Collaborative filtering helps us cut through the noise and deliver truly relevant content. Collaborative filtering isn't a single technique. It involves two main approaches that often work best together. First, we have user-based filtering. This is where the system finds users whose tastes are similar to yours and recommends items they've enjoyed. It's excellent when you have clear user segments like sports fans or tech enthusiasts. Second, there's item-based filtering. Here, the system identifies items similar to what you've already engaged with. This is particularly effective for helping users discover new topics or content outside their usual interests. In production systems, you'll often see a blend of both. Start with user-based for reliable results, then introduce item-based for diversity. Now, about the math, it's simpler than it sounds. We represent each user's taste as a vector, a list of numbers where each number shows how much they like a content type. To find similar users, we calculate cosine similarity. Cosine similarity tells us how aligned two user vectors are. A high score means they like similar things, allowing us to confidently recommend what one user liked to the other. It's a powerful way to turn abstract preferences into actionable insights. In the world of recommendations, features are everything. These are the signals derived from every user action, every click, like, share, or even how long they dwell on content. These signals feed our algorithms. Think about engagement velocity, how quickly a user interacts after seeing content. Fast clicks often mean high interest. Content freshness score balances new, potentially viral content against proven popular items. Social proof signals are also powerful. If your friends engage with something, you're more likely to care. And dwell time, how long a user stays on a piece of content, is often a better predictor of interest than just a simple like. Traditional systems process data in batches, often overnight, meaning recommendations can be stale by morning. But modern systems, like a leading short video platform, process interactions in real time. A user clicks a video, their preferences are updated immediately, and their recommendations refresh in under 50 milliseconds. This instant feedback loop is what makes these platforms so incredibly addictive and responsive. It's the difference between static suggestions and a truly dynamic, personalized experience. You've built a brilliant new recommendation algorithm. Now, how do you prove it's actually better?
You can't skip A/B testing. This framework is your scientific method for validating improvements. It splits your users into groups. Group A gets the old algorithm, your control group, while Group B gets your new algorithm, the treatment. The goal is to measure which version performs better using actual quantifiable metrics, not just intuition. Setting up these experiments requires careful thought. Each user must be consistently assigned to the same experiment variant. We often achieve this by hashing a user ID to get a consistent assignment. This prevents results from being contaminated by users switching between versions, which could skew your data. What metrics truly matter? Click-through rate, or CTR, is a good start, the percentage of recommendations clicked. Dwell time, the average seconds users spend viewing content, indicates deeper engagement. And session length, how long users stay on the platform, is often the ultimate success metric. Remember, you need statistical significance to confirm your results are real, not just random chance. Typically, a p-value less than 0.05 is the benchmark. All right, we've covered a lot of ground today. We started by understanding the fundamental principles of collaborative filtering, exploring how both user-based and item-based approaches work, and even touched on the simple math behind cosine similarity to find similar user preferences. Then we dove into the critical role of real-time feature engineering, discussing how every user action becomes a vital signal and how instantly processing these signals leads to highly responsive and engaging recommendations. Finally, we explored the indispensable A/B testing framework, learning why it's crucial to scientifically validate our algorithms and what key metrics like CTR, dwell time, and session length tell us about performance. By now, you should feel confident in understanding the core components that power today's most engaging platforms. So for your self-assessment, what's one real-world scenario where a batch processing recommendation engine would fail, and why would a real-time engine succeed?